Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about a very important library which is called as Numpy. So till now you can actually see we have covered till advanced Python concepts where we discussed about iterator, generator and decorators. Now we are moving to a new module which is called as data analysis with Python. So here we are going to focus on some of the libraries like Numpy, pandas, some visualization libraries like matplotlib, cbon, which are fundamentally used for data analysis. And out of all this particular library, Numpy is super important because even in deep learning modules also we will be using Numpy some or the other way. Numpy is like with the help of the library of Numpy, you will be able to see that we'll be able to create arrays, we'll be able to work with matrices, and all this operation that we specifically do, like mathematical operations, it will be very, very fast. Okay. So in this video, we are going to discuss about Numpy, how to probably create arrays, how to work with arrays, how to work with matrices with the help of Numpy itself. So first of all, as usual, we will go ahead with the definition. So here you can see Numpy is a fundamental library for scientific computing in Python. It provides supports for arrays, matrices, along with a collection of mathematical functions to operate on these data structures. In this lesson, we'll cover the basics of Numpy, focusing on arrays and vectorized operations. So first thing, whenever you create an environment, specific new environment, Numpy is not by default installed. So there are two ways how to probably install it. First of all, go to requirement.txt, go ahead and update Numpy. And just go ahead and in your terminal, you just need to go ahead and write pip install -r requirement.txt, which I've already shown you. One more way is that directly in the Jupyter Notebook file itself, you can just go ahead and write pip install. Okay, so let's say I will just go ahead and write pip install Numpy. And when I write this, you'll be able to see the installation will happen. And already, since I'm using the same virtual environment, so here it shows that requirement is already satisfied. So when we go ahead with the further sessions, so like wherever there is a library that is required, we will be installing either in this way or directly updating in the requirement.txt. So this is the first step. Now, as I said, what exactly is Numpy used for? It provides support for arrays and matrices. So first of all, for using Numpy, we need to import it. So for importing it, I will just go ahead and write for Numpy as np. So np is nothing but it is just an alias for Numpy itself, right? So we don't have to write Numpy dot at every places. We can directly use np dot. Okay. So this is the first thing that we really need to do. Now we will go ahead and I'll show you how to create arrays using Numpy. Okay. Now, first of all, we will go ahead and create a 1D array. Okay. So a simple 1D array, a one dimension array, how it is basically created. I will create a variable called as AR1, and here I will write np.array. So np.array is a function which will actually help us to create an array. And inside this, I can give list, I can give tuples. Let's say if I just give one list like this, 1, 2, 3, 4, 5. Okay. Now, if I go ahead and execute or print this array, okay. So here you'll be able to see that as soon as I execute this, I'm able to see that I'm getting an array itself, right? Print AR1. By default, you'll be thinking that this is a kind of a list format. No, it is not. So if I go ahead and see print the type of ARR1, okay, ARR1. So here you'll be able to see that it is a numpy.nd array, n dimension array. Okay. If you also want to see the shape of the array, like what exactly is the shape of the array, so I can go ahead and write ARR1 dot shape. Okay. If I execute it, here you can see it says that, hey, it has 5 comma blank. So it is a single dimension. Whenever there is a single dimension, only one number will be available. Okay. Like comma dash, like that, it will be blank. So whenever we have blank on the other sides, it is basically talking about single dimension. Here no specific rows or columns are there. Okay, let's say I want to convert this into a rows and columns. Let's say I'm right now, many people will be thinking, hey, these are like one row and 5 columns. Nothing like that. Whenever we work with single dimension array, there we don't try to provide columns or rows, right? There it is just treated as a single dimension array with 5 elements. Okay. Let's say that I want to probably go ahead and do one thing. Let's say this is my array that I've actually created, array 2. Okay. So now I want to go ahead and reshape it to a 2-dimension array. So what I can do, I can go ahead and write arr2.shape. Okay. And here I will just go ahead and write 1, 5. Let's see whether this will get executed. So here it says tuple object is not callable. The reason is very much simple. Here we need to provide with this particular brackets. No worries. Tuple object is not callable. Let's see array dot. Sorry, I wrote reshape. I wrote shape. Okay, it should be reshape. My mistake. So it should be reshape 1,5. Now you can see that very much simple, right? A single dimension array is basically having one braces entry and one braces closing, right? But here you can see there are two braces that is basically getting opened and two braces that is basically getting closed. So this becomes a 2-dimension array. In 3-dimension array, you will be able to see that there will be 3 braces that will be opening and 3 braces that will be closing. Okay, so this is how you can actually identify. Now, since I have told, hey, I need to reshape this 5 elements to 1,5. 1,5 basically means 1 row and 5 columns, right? Understand, this 1,5 basically means 1 row and 5 columns. And anyhow, if I probably go ahead and see, here the total number of elements will be 5 only, right? So that is the reason we have reshaped to 1,5. If I go ahead and reshape to 1,4, it will not work. Why? Because there are 5 elements. How can I reshape to 1,4? Like 1 row and 4 columns. The total should be 5 elements. Right now, only 4 elements are basically there. So here I will just go ahead and write 1,5. This basically means 1 row and 5 columns, right? So total, how many elements it is becoming? 5 elements, right? I will not add 1 plus 5. Don't do that mistake. Okay. So once I'm reshaping it, I'm able to get this. Okay. 1, 2, 3, 4, 5. Now you may be thinking, can we go ahead and create like this directly? Yes, you can do it. So if I go ahead and write arr2 dot, and if I use np dot array, and here, let's say I go ahead and use my nested list, right? So I will go ahead and just use a list within a list. Okay. So here you can see that I will be able to get an arr2 dot shape. If I do dot shape, then again here you will be able to see I'm getting 1 row and 5 elements. What did I do? I just used list inside a list. Now let me do one more thing. Let me just go ahead and print like this, and let me add more elements. Now I'll go ahead and add one more list. Okay, like let's say 2, 3, 4, 5, right? And this also basically has 5 elements, 2, 3, 4, 5. Now if I go ahead and print arr2, and I also go ahead and print my arr2 dot shape. Okay. Now if I execute it, here you can see this time I'm getting the first row and the second row. All the elements 1, 2, 3, 4, 5 is present in the first row. 2, 3, 4, 5, 6 is present in the second row. That basically means how many columns? 1, 2, 3, 4, 5 columns, right? So the shape will be 2,5. Why 2,5? Because there are 2 rows and 5 columns. Now I hope you are able to understand. This is also 2-dimension array. Why? See, 2 times it is opening over here and 2 times it is closing over here, right? So it becomes a 2-dimension array, right? So I hope you got an idea. And this array what I have actually written is nothing but 2D array, 2-dimension array, right? So it is a 2D array, right? Single dimension array is nothing but this, right? So it is a 1D array. I'm just going to write down the comment so that you can refer this 1D array. Okay, perfect. So 2D array, 1D array, we have discussed about it. Now let's go ahead and create arrays with some of the inbuilt function. Okay. So for this, I will just go ahead and use np.arrange function. Now inside this arrange function, let's say I want elements between 0, 10. And the third parameter that you will probably be seeing is step. Okay. So if I go ahead and write 2, that basically means I have to skip every one element and go to the second element and display it. So what it is getting displayed between 0 to 10, 0, 2, 4, 6, 8. Now there are 5 elements. If I want to reshape this into a 2-dimension, I can basically do, since there are 5 elements, I can do 5, 1 or 1, 5. If I do 5, 1, what does this basically mean? That basically means I have 5 rows, 1, 2, 3, 4, 5, and 1 column, right? So this is how we can actually reshape or convert a single dimension array into a 2-dimension array, right? So this is how we can basically do. Now we are also going to check out some of the inbuilt functions that are present in NumPy array. So one is np.ones. So if I go ahead and use np.ones with 3, 4, that basically means it is going to create a 2-dimension array with 3 rows and 4 columns, and all the elements is going to be 1. So see over here. So 3 rows, 1, 2, 3, and 4 columns. Now why you may be thinking why we have this function? See, when we see in deep learning, right, some of the some of the inbuilt functions of NumPy, right? Like np.1s or np.0s. Let's say I have to initialize the initial weights to 0. I can directly use this inbuilt function and create it over there, right? So quickly it helps us to create all these elements. Otherwise I had to write multiple lists over here and then probably convert that into a NumPy array, right? Now this was one. There's also an option to create an identity matrix or array. And here for that we use np.I, and if I just say, hey, what is identity matrix? It's like all the diagonal elements will be 1, remaining all will be 0. Let's say if I do 3 cross through, then here you can see in diagonal elements I have 1, remaining all the elements are 0. So this is basically an identity matrix. Okay, so I hope you have got an idea with respect to np.array, how to reshape it, how to see the type, and what all things you really need to do while reshaping it. Okay, so all these things has been spoken about, right? Again, I will quickly write this kind of code over here so that you will be able to see this. Array is array shape you want to see, number of dimension you want to see, 2 dimension or 1 dimension, you can use n type. Size, number of elements you want to see, you can go ahead and write array.size. If you want to see the data type of that particular array, you can just go ahead and write ar.dtype. Output may vary based on the platform. It can come in 64 in 32. It depends on the platform. Item size in bytes, like how much bytes is specifically used. Okay, so all these things are there. So let's go ahead and execute it. So here you can see 1, 2, 3, 4, 5, 6, shape 2, 3. This is in 32. This is my system. So I will just go ahead and write in 32. In your system, it may vary to some other value based on the operating system that you have, right? So perfect. This is mostly about some of the amazing attributes. I'll write down a comment, attributes of NumPy array. Okay, so perfect. So here you have this, right? Now let's do some kind of vectorized operation. Okay, vectorized operation. So NumPy vectorized operations. Okay, now what I am actually going to do is that I'm going to perform some amazing operations over here. And here you can go ahead and create this quickly. Okay, NumPy vectorized operation. So first of all, I will go ahead and write array1. Let me just go ahead and create np.array, and here I'm going to probably give some elements like 1, 2, 3, 4, 5. Okay, again I will be using another array which will be np.array, and here I'm going to basically use 10, 20, 30, 40, and 50. Okay, I've just defined something over here, right? So first of all, I will go ahead with element wise addition. Okay, element wise addition, and here I'm just going to go ahead and print. This will be my addition, and here let's go ahead and let's say I will go ahead and write AR1 plus AR2, right? So if we really want to perform element wise addition, that basically means what? This one will get added to this 10, 2 will get added to 20, which is present in the same index inside that particular NumPy array. That all elements will get added, and directly we can do that but just by using this addition operation. Perfect. Now what I will do, I will go ahead and also perform element wise subtraction. Okay, so let's go ahead and do that. So here I'm actually going to write print subtraction colon, and here let's go ahead and do this comma AR1 minus AR2. So with respect to element wise subtraction, we can basically do this. Similarly, if you want to do multiplication, again all you have to do is that just do the same copy paste over here and just write AR multiplied by AR2. And similarly, you want to do division, you can also do that, perform modulation operation, whatever you think you really want to do. So all this, the best thing about NumPy is that they are just going to do element wise. Element wise basically means the element that is present in the same index, automatically this will be considered. So if I go ahead and execute it, here you can see this is all my output that I'm able to get. Okay, and remember one thing, that all the return type will also be an array. Okay, so this is one very amazing thing. Let's talk about some of the universal functions. Universal functions basically means some functions that applies to the entire array, right? So let's say I'll go ahead and write arr np.array, and here I'm going to basically use an element 1, 2, 3, 4, 5, 6. Okay, let's say. Now what I'll do first, universal function that I'm going to apply, which is available in np.array, it is nothing but print, let's say I want to perform square root. So np.sqrt function is basically there. And here I'm going to just give the array, right? Automatically the square root is going to get performed. There is also a function which is called as exponential, right? We can also perform this. So for that, we'll go ahead and write np.exp exponential. And here I'm going to basically use this array. Okay. Next thing, I will just go ahead and perform sign. Now the best thing is that whatever operation I'm applying, this will also get applied element wise, right? So here I can also go ahead and use np.sign. Okay, sign. And here also I can go and give my array. Okay, so this is also another inbuilt function. And similarly, you can go ahead and explore a lot. So I'll just go ahead and apply natural log also. And for that, I will just use print np.log. Okay, I'm going to do this, and here is all my function. Okay, sorry, np.log of array. Okay, so here you can see with respect to all the values, all this operation is basically taken place. Okay. Similarly, mathematical equations also you can perform. It is up to you, whatever things you really want to perform. Now coming to the universal function. So let's go ahead and write my universal functions. Now inside this universal functions, funcs, I'm just going to basically go ahead and define. Now see, universal function is done, right? So let's go ahead and do the slicing operations, array slicing and indexing. Okay, array slicing and indexing. Okay, so we will go ahead and perform this entire operations with multiple examples. So guys, now let's go ahead and perform array slicing and indexing operations. And here, let me just go ahead and write arr is equal to, let me just go ahead and create a two-dimensional array. Now this time when I'm creating a two-dimensional array, I will take some of the elements like 1, 2, 3, 4, 5, 4. Then I will go ahead and create my another list where I will take 5, 6, 7, 8. And let me just go ahead and take 9, 10, 11, 12. Okay. So here in short, you have 3 rows and 4 columns, right? So let's go ahead and print this array. Okay. So here I'm just going to use array colon, let's say a new line. And here I'm going to just display this array itself. Okay. Now let's go ahead and access the element. First of all, I will just go ahead and print this. So here you can see array takes 1 or 2 positional argument. Array. Okay. This was the problem. Let me just close this up. I have to use a two-dimensional list over here. So this is specifically my array. Okay. Now my question is that how do I pick up or access a single element from this particular array? Okay. Now here what I'm actually going to do here specifically, let's say I want to go ahead and pick up one element. Okay. Now one very important thing over here is that you should know the rows and columns, right? This is how your entire two-dimensional array is basically built on. Rows and columns. Let's say I want to pick up this particular element, array of 1, right? This one element. So this is my array, right? Now what I will do, I will just go ahead and see which index. Let's say I have to probably go ahead and check out which row it is present on. So right now 0th row, right? So if I go ahead and write 0th row, I will be able to get 1, 2, 3, 4, right? Now out of this, which column I have to probably retrieve? I need to retrieve this one value. So obviously it is available in the 0th column. So always remember, indexing basically starts with 0 and 0, 1, 2. And you always need to probably look at whenever you are accessing any values, right? You have to access in such a way that you have to focus on the indexes. It can be the row index or it can be the column index. So once I go ahead and execute it, here you will be able to see that I'm able to get the answer. Okay. Now let's say I want to probably go ahead and pick up elements like 7, 8, 11, 12. Now how do I do that? Now 7, 8, 11, 12. Okay. 7, 8, 11, 12. Understand it is available in which row? It is simple that it is available in second and third row, right? Now second and third row, how can I write? Okay, I can basically say start from second row, go till the end of the row, right? So it can be any number of rows. So 7 and 11, I will be able to pick up this two columns, right? Sorry, these two rows. So if I go ahead and execute it, so 2 colon 0 1. Okay, I have to write 1 colon. I'm extremely sorry. So here you can see I am able to get 5 6 7 8 and 9 10 11 12. Now with respect to column, I have to focus on which columns? 0 1 2, 2 and last, right? So here I will go ahead and write 2 colon, right? So once I do 2 colon, what will happen? I will just go ahead and pick up this particular columns, and out of all these results, what I'm actually going to focus on, I'll just be focusing on this column and this column, so that I get 7 8 11 12. So once I go ahead and execute it, here you'll be able to see that I'm able to get the answer, right? Very much easy, very much amazing over here. Now let's do one more exercise. Okay, so here let me just go ahead and write print, and let me go ahead and write one more over here. Let's say I go ahead and write print ARR, and I'll say 1 colon. Okay, now when I say 1 colon over here, let's say that I want to pick up 3 4 7 8. Okay, now 3 4 7 8, let's say that if I want to pick up 3 4 7 8, you know that I have to focus on which all columns? I have to focus on 0 and first column. So 0 and first column, how do I write it down? So I will go ahead and write 0 colon 2. That basically means it indicates I have to read from 0, and before the second column, that is first column, I have to read all the elements over there. So if I go ahead and execute it, here you'll be able to see 1 2 3 4 5 6 7 8. I got it. Now I want 3 4 7 8, so I have to focus again on the last two columns. So now my next specific value will be, or I can also write like this in a separate brackets, or I can also go give a comma and just go ahead and write 1 colon, right? So once I do that, so I'm able to get 2 3 4 1 colon. I have written 0 1, so it should be 2 colon. Okay, so 2 colon, you'll be able to see that I will be having this 3 4 7 8. So you can go ahead and pick up any kind of elements based on this index mechanism itself, right? And this is very much simple, and this is very much clear, I hope, and you can still practice more ways. Like if I want to go ahead and pick up 6 7 10 11, let's do this. Okay, let's do this. If I want to go ahead and pick up 6 7 10 11, so here I'm going to write array of 6 7 10 11 is present in which rows? First of all, I have to focus on the rows. It is on the first and the second row. So like I'll just go ahead and write 1 colon. So here I'm actually going to get 5 6 7 8 9 10 11 12. Now my column needs to focus on this first index and second index. So what I can actually do, I will go ahead and write 1 colon 3, right? So till the third index, before the third index, I will be able to get the element. So here is my 6 7 10 11, right? So here you can actually see that how easily and how beautifully we are able to probably do the slicing operation and get all the values. Okay, now if I want to also go ahead and modify the elements, modify array elements, right? Array elements, I can also do that. So for that, I'll just go ahead and say, let's say I want to go ahead and take this array and replace the 0th, 0th element with 100, right? Right now it is 1. If I go ahead and execute it now, right? If we go ahead and print the array, you will be able to see that I'm able to get this particular element over here, right? So these are some of the operations. You can again replace multiple things. You can replace multiple segments of numbers also. Let's say if I go ahead and write print colon, and here I'll go ahead and write, or let me just do one thing, array, and let's say that I want to go ahead and replace 1 colon, all the elements from first row till the last, and all these elements with 100. Now if I go ahead and print the array, I'll also able to do this operation, and here you can see all the elements after the first row is basically having 100, right? Before that, I have basically changed this particular element. Perfect. So I hope you are able to understand this. Now let's do some of the practical applications with respect to array again. First one is a statistical concept. Okay, so I'll focus on statistical concept, which is basically called as normalization. Okay, so we will be learning about normalization as we go ahead with machine learning. So normalization, you know what exactly it is. I need to change my data to have a mean of 0 and a standard deviation of 1. Okay, so we usually do this, and for this there's a formula right now. No need to focus more on that, because anyhow I'll be discussing about that. So calculate the mean and standard deviation. Let's say this is my array we will go ahead and calculate the mean and standard deviation. For that, we can use np.mean of data, np.standard deviation of data. Then we have normalized data. It is nothing but data minus mu divided by standard deviation. This is also called a standard normal distribution. And here we can probably go ahead and display our output. So this is how my output looks like after initially this was my data. After normalization, this is what my data is. Normalization is nothing but converting this data in such a way that your mean is 0 and your standard deviation is 1, right? And it is specifically used in statistical concepts, and we do a lot of things with respect to that. Okay. Let's take one more operation with respect to statistical operation, how to calculate mean, median, mode. So here I will be giving you one more example. So here you can see np.array, np.mean, np.median, np.standard deviation, np.variance, right? So these are some of the statistical concepts that we do. If you really want to find out mean, then we can go ahead and write np.mean, median, np.median, standard deviation is nothing but np.std, and variance, you can specifically use np.variance. And these are some of the important concepts that we specifically use in statistics, right? So if I go ahead and execute it, you'll be able to see all these values. Perfect. Now let's do one thing. Let's quickly do one more operation that I am really interested in this. And whenever you work with pandas later on, you will be using this. That is nothing but logical operation. Okay. Logical operations. Let's say this is my data, and here I'm going to basically use np.array. And let me just go ahead and create the elements like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I can go ahead and apply some logical operations. I can just say data greater than 5. Now, what will happen when I write data greater than 5? It is just going to give me an array which says whichever value is greater than 5, that will be true, right? And whichever value is less than 5 is basically false. Okay, so it is basically applying a condition on this particular data. Now let's say that I just want to retrieve all those elements that are greater than 5. So all I have to do, I will be using an indexing where I will say, hey, data of data greater than 5. And here you can see that I'm able to get the value that is nothing but 6, 7, 8, 9, 10, right? And this is super important because in pandas, when you do the data analysis, because we will be having an Excel sheet, we'll be having a data frame there, we specifically apply this kind of logical operations within the arrays itself, right? So any conditions you can go ahead and write. Let's say I will go ahead and write another condition where data is less than 8. So let's say all the elements within 5 to 8, right? Greater than or equal to 5 and less than or equal to 8. So here you can see an error is there. Okay, let's do one thing. I'll go ahead and write and there also it is not working. So let me do one thing. Let me do one thing as such. I'll just use some brackets so that it'll become simple for it. And here I will use another bracket. Okay. Data. Okay. Here I'll close it. Okay. Now here you can see that I've used this particular brackets. The reason was that why we are getting an error, because there were many things that we were probably putting as a condition, right? And it got confused. The compiler also got confused. So this AND will not work. Instead, logical AND will specifically work over here. So here you can see that I'm having the value 5, 6, 7, 8. So multiple types of condition you can put. You can use OR, you can use AND, whatever things you specifically want, right? Anything you can actually use it. It is up to you. So I hope you were able to understand this particular question, this particular topic, sorry. And yes, this was it from my side. In the upcoming session, we'll be discussing about our next library, which is called as pandas. So here, in short, we have discussed about NumPy. And as we go ahead, we'll be still discussing about NumPy. Even in machine learning, we'll be seeing a lot of multiple examples with respect to NumPy. So yes, this was it. I will see you all in the next video. Thank you. Take care.